Thank you. And I'll admit it straight away, I am very, very old. So don't worry. I'm sort of here to help, as we all are, but all the problems related to water loss, I've gone through them many, many times. I should say, really, this afternoon's the exciting bit for me, because I think pressure reduction, district metering, etc., this is all really getting into the real meat of how you're going to save lots of water. And what we're having to do this morning is go through terminology and methodology so that everybody who's attending the conference for the rest of the week is starting on the same level. They're understanding what people are talking about. Okay, so you might be hearing quite a few technical details, data details, when you really just want to go out and find leaks and fix them. But I think to having a holistic approach and thoughts about every different aspect of reducing the losses and saving water for your company, your town, your country, then you need all these bits of knowledge that we're talking about this morning. But this afternoon is going to be the information that's actually going to give you the tools to go out there and save water. So, water metering and apparent losses. Well, David talked a little bit about apparent losses, how it fits in with the system. I'll talk a little bit more on that. But the thing you've all got to be cautious of, because you all come from different places, different regions, different countries, etc. You do things differently, and you see us sort of so-called experts come along, and you listen to us thinking, wow, they know everything. But believe you me, certainly in every country I've worked at, and I've worked in many, we do stupid things at times. I'm from Australia. I've lived in Australia now for about 30 years, and these are some of the stupid things we do in Australia. We build balconies with no doors to get out to the balconies. So we might not be as bright as what you think we are. We decide to put something to stop you going in your driveway once we've built a driveway and built a house for you. So you've got to go round it. Now, I used to have about 50 photographs of stupid things we do. And I've had to cut them down because I end up just talking about stupid photographs all the time. But if you hear something from us that you don't think is quite right, or doesn't fit in quite right with yourselves, with your thoughts on how you do things, just bear in mind what we're telling you might not be right for you, for what you do. In fact, it might even be a bit stupid, because there might be better ways of doing things. And we're learning all the time. I learn every day. I may well have worked for the water industry for 49 years. I've been a CEO of a corporation. I've specialised in water losses for years and years and years. I still learn. I still want to learn. I want to know that magic for how to achieve something better, because it's still out there. And you might have the answer, so I'm happy to talk to you during the week. Right. This is what I'm supposed to be talking about. I'm supposed to have a little gun here that points to it, but you see, it can point up there, but it can't point on there at all. So maybe a bit stupid, but anyway. Apparent losses, you can see how it fits in here with what David was talking about, the system input, when we do the IWA standard water balance. And it's all about trying to find out what the non-revenue water really is and how that splits down. You can see apparent losses here is moves on to be called unauthorised consumption and customer meter inaccuracies. It's actually more than that, and you'll see different diagrams. But what we're trying to do is split out really apparent losses away from real losses and unbilled authorised consumption. We're trying to say there's other things as well as those. There's another diagram you might see if you pick all the booklets up. Here we've got apparent losses, also called commercial losses to some people. where it splits down to 4 specific items. It's all the same really, because those 4 fit into the other 2 anyway, so it doesn't matter which sheet you pick up at what time, or even if you write your own, because there might be something specific to your area or your country that would fit in there. What you've got to be very, very careful of is not having the cheat sheet that David talked about, that Ken used to do a lecture on. In fact, I think Ken should still do lectures on the cheat sheet, so it was so good. People try and reduce the real losses, the physical losses, from a performance point of view, or a reporting point of view, by subtracting as much as we can of it. Let's go out and find everything we can and put a stake and a claim in for it. And it's the wrong way to go about it. You need to be honest to yourself, if nothing else. Okay, well, one of the issues we talked about, and David also talked about this a little bit, was unbilled authorised consumption, and he mentioned things like firefighting. Well, in the presentation here that you're going to get a copy of, there's a list of other things here that can go on. I'd say this side of the business is very much related to where cheat sheets can also come in. It's definitely related to, cheat sheets are related to unbilled authorised consumption and real losses. So again, be careful. This is a guideline that's been put out recently in some software notes. But there's many others. This just gives you an idea, that's all. Okay, one of the main causes for apparent losses is data transfer errors. People who are recording things, whether they're meter readers, whether the people in the accounts office, however your system is, there will be some errors. Even if you think it's all controlled by computers, controlled nice and well, there will be some errors. And these errors creep in to give you some wrong figures. Estimated readings, very common. Lots of meters don't actually work when they're supposed to be. Part of an area might be out for some reason. They may not have actually metered some particular areas. So you introduce estimated readings. If you get wrong with this figure, and you don't do your homework and testing out some zones to see what they are, then this is going to badly influence what your real losses actually are. Metering errors. I'm going to talk about meters generally in a minute or two. But meters, don't believe them. They tell you lies. Number one lesson is it gives you a number. Is it right? Generally it's not. It'll give you an indication that it might be right. I'll tell you why, but don't believe it straight off. Prove it. Test it. You don't have to go into fancy, expensive systems to test them. You have to understand a meter and how it works, what its qualities are, what will happen if you move it. But you need confidence. Is it giving you approximately the right figure? I'll give you some ideas on how to test that. And theft and illegal connections is the other big one. Now, I've seen some photos from Ronnie McKenzie, who works in South Africa, and I've seen horrific photos of thousands of illegal connections with more illegal connections off the other illegal connections. Fantastic photographs. It's obviously quite a problem here, and I would say in a lot of the countries I've worked in, also a big problem. Probably the UK, not as big a problem. Australia, not as big a problem, I would say. Canada, not a big problem. But certainly some of the poorer countries I've been in, like small Pacific Islands, etc., massive problem. First of all, nobody wants to pay for water, and a lot of people aren't in a water supply zone, so they make their own connections into the water main. And when they do that, they generally create leaks as well. So it's not just a theft of water problem, but it's the quality of the illegal connection joint that they make is also a problem, because it will probably leak. How many of you, just put your hands up, think you have a lot of theft of water in your areas where you work? Okay, that's not too bad. That's probably less than 10% of the group. Okay, and it might be that you don't know. In fact, I suggest you don't know. Because I'd have thought 90% would have put their hands up, really. So maybe you're better and I should be sat there and you should be stood up here talking. I'm not too sure. Because only 10% with illegal connections, that would be a worry. I don't think that would be quite right. I would say in a lot of the Pacific Islands, for instance, in Thailand, in Vietnam, places around Asia that I've worked, water losses through theft is enormously high. You're talking 30, 40, 50% of the water totally lost. So maybe I'm suggesting have a look at this afterwards somehow. It's very hard to find illegal ones, but you can do. You can do total checks on areas, and I'll give you some clues how to do it. David also talked about the top-down accounting. You see, as well as finding your actual water losses for a good index, you also use this top-down approach and the bottom-up of accounting approach for determining your apparent losses as well. And you do some sampling in areas. You can do smart metering. This can tell you an awful lot that you might be allowing as an estimate otherwise. And whatever system you do for working out your apparent losses, you should have an audit trail, a paper trail, a computer file to prove exactly how you've arrived at your particular figure. Because an awkward CEO like me will not believe you if you just come up with a figure. I want to see how that's been audited, what proof there is, what testing have you been done. And people get to know that over a period of time. So you could well be the leaders, you could be the data gatherers, but wherever, you start a good system of keeping a log of everything you're doing to test out. Now the top-down accounting for all water, like David talked about, is looking at the total water that's going into the system and then trying to break it down into its component groups. The bottom-up approach that David talked about as well is, as he said, looking at, first of all, night flows. Well, you might not have all the night flows to be able to look at, but you might be able to have some areas where you can get that information, and it's just not as hard as most people think to actually gather. But again, that can be misleading. I mean, to be able to do both, the top-down and the bottom-up approach is making sure all the figures that you're gathering, especially if you've got a good paper trail of how you're accounting for your apparent losses, it's making you have confidence in anything else you do, to move forward to a next step, to where to spend money in a wise way to get savings. Remember, this is really what all this is about. It's to identify in the end, where do we send people, where do we spend money to reduce losses to the best effect. And gathering all this information to start with is so important. I'll come back to some of those reasons, but the RWA brought out this type of graph, or diagram I should say, for how to get savings on anything you do. They did an overall one for real losses, and then they've done this one for your apparent losses. So one of the things you can do on water meter errors, or I should say one of the things I did at least, was for every 15,000 properties, I'd want 150 meters actually tested on site. Just to see, every year I'd want this, just to see how they are actually measuring at 2 different flow rates, a high flow rate and a low flow rate. How accurate are these meters? I used to take the meters out and send them away to be tested in a laboratory on a workbench, but we found that a lot of the meters actually got damaged whilst they were being taken out, being transported, and we were not getting the right information. So we set up simple systems to fill up known volumes of tanks at 2 different flow rates, low flow rate and a fast flow rate, to see what actually went through the meter when we knew the volume of the tank it was filling. And we also found out through this that the age of the meter is not the critical thing. Most water companies have an issue with, or have a rule to say, we will replace all our meters every 7 years, or every 5 years, or every 10 years. Every company you go to, it's different. And I don't know who comes up with these figures, really. What I found out, after some good advice from people who know more about meters than I do, is that meters, even if they under-measure, they will generally under-measure correctly for a long time if you know how much they're under-measuring. They will repeat that same amount. So a good water company can still use meters that are 10 years old if they are repeating the same amount of water that's going through. And you can make allowances for this in your apparent losses. This can save a company a lot of money rather than say, changing meters every 5 years or 7 years. They can go on for 10, 12, 14, as long as you are making allowances for that. And the repeatability, once the repeatability stops, the meter quickly goes all over the place. Low figures, high figures compared to what it should be. But again, that can be identified. Usually if you're doing good scrutiny of your meter readings and you're getting admin reports about an unusual meter reading here or there, you can go out and test those. It's easy to do. It's not hard, very easy. You get a good man really committed to looking after the meter fleet, as you call it. They want to make sure they're giving you good information. So you encourage them however you can and make sure they can give you that information back. So water meter errors, you can find out. You can go out on site, do simple tests. Errors on estimate of unmetered consumption. Okay, that sounds a big problem to people. There's areas where that's not metered or issues that's not metered. You can do trials on these areas. I think years ago, David, in Northwest Water, you arranged where there was no metered areas to have a big bulk meter put in, just to see, and we tested exactly what the losses were to subtract that, just to see what large complexes were using as far as water was concerned. And yet we didn't actually have meters on there, we just put one on, just to find out, to measure a large group of properties. So you can do tests every year, and again you need the paper trail. What tests have you done to reduce your errors on unmetered consumption? On the other side, errors throughout data acquisition process. This is a difficult one, you know, when you're gathering all your meter readings, how do you know how accurate the people are reporting them? Now, really, I found no better way than going out and actually talking to the people. People who do their job every single day, they know the problem in the job. They know what the problem issues might be. They know when they might be under pressure for how things are recorded, or whether anybody takes any notice of what they've recorded. That often is a delay factor that might frustrate them a lot because they're handing good information in. So you've got to go out and spend time with the people who's actually doing the recording, with the admin people who are doing their work, to find out the facts. And that's the best way I've ever found out of seeing where the errors might be in gathering the data. Smart metering is altering this a lot. When I say smart metering, we're talking about domestic metering generally, where we put in on meters that have a recording to say this is how much how much water's passed through me in the last hour, the last day, the last week, the last month, and that's often automatically transmitted back to a base somewhere. There's still errors in that. Sometimes they can't transmit the data for whatever reason, it's not picked up. The signal might not be able to go past a tree or a bush that's in a garden and things like that, so you're not gathering all the information that you think you're actually gathering. But again, if you've got a really keen person in charge of your meter fleet, they will be coming out with these unusual ones to go and have a look at and go and inspect on site. And that's what it actually means, actually going out on site to see why are we not getting readings correctly from these areas. So what I'm talking about here is really an audit of things that you've got to put in place continuously to get better information. Now, unauthorised consumption is one of the most awkward ones. The theft of water, taking of water when they're not supposed to even, might be drought restrictions on, etc. Again, smart metering helps that, but also I'll talk this afternoon about district metering and step testing, and I'll show you then really how you can find some illegal connections as well. Because people who put illegal connections on are often smart. They don't want you to see it. They'll put it in a place that's not easily seen quite often. Unless there's just so many people stealing water in an area, they just get past bothering. They just put it on an open main. And I know that goes on in lots of countries. Okay, now there's a group been working on apparent losses, and like David was talking about for the ILI, which is an index of water losses, there's been a group trying to work out an apparent loss index. My advice, I'll tell you about it now, but my advice to you is you've got bigger problems perhaps than worrying about comparing yourself with other companies on their apparent losses. What this group basically decided is that in a well-managed utility that's on top of most of the problems, that metering loss may be reduced by about 4% of the authorised metered consumption, and the unauthorised consumption would be less than 1%. That's in these extremely well-managed companies. Okay, and using that information, they say there's a reference apparent loss of 5% overall. So they're using that as a ratio now. I would say this is not general throughout the world. There's just some trials being done on it to see whether it's worthwhile doing or not. And these are some, although it says what countries they're from, these are really individual companies within those countries. So the graph that's been put out is a bit misleading, I believe, and it's again trying to show to get to a ratio of 1, and it really shows that a lot of high-income countries can be relatively low, but a few will still be high, and the ones that are high are the ones that don't actually go out doing any audits. That's what's been found out. I think you've probably bigger issues than worrying about comparing yourself, but nevertheless, it's something that's there that can be used. The reason why I say I don't really advise you to do it at the moment is something like what David was talking about, pressure. You know, you can demotivate people from doing things, and that's why I wouldn't worry about this aspect at the moment. I don't want you demotivated. I want you to go out and try and find everything you can out about your particular system. All right, we'll talk about meters for a little bit, and the type of meters that's used in water distribution systems. These are the general ones. There are others. Semi-positive displacement meters are really a small mechanical meter that has a space inside that fills up and empties out as the meter's going in as the water's going into it. Works very quickly. It's a known accurate compartment that's inside that fills up. So its reading has been relatively accurate for the last 40, 50 years they've been using these. The design's been altered a lot in that time, but nevertheless it's a type of domestic water meter that's been used commonly for years and years and years. Now there's also turbine meters, and there's various different types. Actually there's many different types of turbine meters, both for domestic purposes and for distribution mains themselves. Turbine meters have been accepted more into water utilities for metering of houses and properties because they're probably a bit simpler inside. They were advertised certainly to start with that they would last for many years longer, but also what companies quite liked is that the tolerances of them to keep to the working specification, they were allowed to overmeasure, whereas semi-positive displacement meters were not allowed to overmeasure. So a company could change all its meters and suddenly be saying this meter reading is correct when they're actually overmeasuring. And what that gives you is an under measurement for your real losses then. So it's distracting. Now over a period of time, as they wear slightly, that over measurement comes down. This actually drove the people who designed semi-positive displacement meters to redesign so they would over measure as well. So they're all as bad now. And even more reason why you should do your tests on site every year. Turbine meters on distribution systems are exactly that. They're a large turbine that it's mechanical. It turns round inside. Problems with them, they can get hit with anything that gets into the water main. Stones, pebbles, dirt, slime, anything. And you can put a sort of box in front a few meters ahead called a straining box to collect anything to stop the turbine being damaged. 1983, there was a massive change in the design of turbine meters to be able to measure low flows. Up till that time, there wasn't a good meter on the market to measure low flows, and it only came about by accident because the American market wanted to be able to measure high flows very accurately, and by sheer chance that same design could measure low flows. So suddenly the water industry could put turbine meters on, using them for measuring how much water is going through distribution mains, and be able to measure with the same meter the high flow range, the medium flow range, and the low flow range. So the world started then collecting nighttime flows as well. Before that, to get nighttime flows, you had to put up a special meter, shut down a system just at night time and measure it with those special meters. They've gone now. Mag flow meters, obviously electronic, was an improvement on them. There's nothing in the middle to get damaged. Ultrasonic meters, very similar, work slightly differently, but again there's a clear bore through the pipe for the water to flow through. Ultrasonic, very expensive, but nevertheless, if set up correctly, will work well. Insertion meters, you get insertion meters of all types actually, turbine and ultrasonic generally. And if people say they can't afford to put meters in to do tests on distribution systems, this is what I advise them to do. Learn how to use an insertion meter, because all you've got to do is then drill and tap your water mains at every point you want to meter, and you can take an insertion meter in, leave it there for a week or a month or wherever, or just one day or one night, get all your readings and then move it to another spot. You'd be doing all that. You could do a whole distribution system for about $5,000. Okay. So people who say they can't afford district meters, I would say do this first. You need to learn how to measure a mean flow velocity if you're using insertion meters. Because inside a water main, water travels at different speeds, and an insertion meter, whatever point you put it into, you're just measuring at one speed. So you need to learn how to develop a mean flow velocity to be able to use them. And as I said before, they all give you a number. Don't believe it. Do more tests on them. Okay, these are a poor example of how to install a meter. Not sure where it is. I think it might be Australia. But it's put immediately after bends, and when water hits a bend, it starts turning one way or the other. And this particular meter is a turbine meter, so it's going to be affected how it spins round according to the vortex and how the water's swirling through. So the worst thing you can do is put a meter straight after a bend, because you'll either speed it up or you'll slow it down and it won't be accurate. The really worst thing you can do is put it after two bends, like this one has been done, because there's all sorts happening with the water in things like this. It's, in fact, I do have a drawing to try and give an idea of the different velocities of water, how it affects once it's gone round a bend. You see there, every section that's been taken shows the different speed of water at each point across it. And where this would hit a turbine, you're likely to get massive misreadings. I've just been chairing a commission in Queensland for non-urban water, for irrigation water. And I was quite surprised when I came across things like this. They've learnt on the irrigation system, they've got standards for lengths of pipe, and they've gone far beyond what people normally do in putting straight pipe in. But they're out in the rural area, they've got plenty of land, they can put it above ground. Look at all these, I was fascinated. You know, the massive lengths of straight pipe just to make sure 100% that they're trying to get a correct reading. The government insists on this, and unfortunately they've got this system of certifying that a meter is working correctly and testing it, but nobody ever bothers to test the meter. They make sure the pipe works right, and then they just say, oh, it's working, it's okay. Whereas I found 90% of them not working correctly. All right, just a quick talk. I'm under pressure here from somebody sat on a seat in front of me, so I'll just... we did a trial for Australia, 7-8 years ago now, on automatic meter reading. Basically, I persuaded the Prime Minister that he needed to do a trial in Australia because all my meters needed replacing. And I thought, well, if I persuade him to do this trial, he'll pay for all the meters, and that's exactly what happened. It cost him about 20 million, which was great. I've been looking at smart metering for 40 years. I thought this is the answer to a lot of our problems. And every 5 years I kept going back to look at what's available now. Well, when I had the possibility of getting all this money off the Prime Minister, I looked a bit harder, and there was some good stuff coming out in America. It's blossomed since. It's absolutely wonderful since. But the ones we got just fit on the side of either an existing meter or a new meter, wherever you want. And the logger could record whatever you want it to. So I got them to record every hour. I wanted to know every hour. And we started just to prove that everything was going to work all right with 1,500 of them, and we moved to 24,000 of them and then 2,000 on commercial. And it went so much smoother than what I thought it would do. The potential benefit was absolutely enormous. I wanted to defer capital. Being a CEO, you don't want to spend as much or more than what you have to. So a big issue to me was not just measuring water, but the information it would give you. If I could get information to prove that we should give incentives to people to take water at a different time of day, I wouldn't have to lay trunk mains then to meet peak hour demand. And my biggest cost was laying trunk mains to meet peak hour demand. So all these options open to you. That's the Prime Minister there. He came round to actually have a look to see where he was spending all his money on, John Howard. He was quite deaf as well as John Howard, so he didn't hear half of what I had to say, especially when I said 20 million, you know. No, he just nodded and said, yeah. But this is what I was after. A typical low flow leak at properties. You see those small dots? It's recording every hour. So if it's recording something every hour, there's water going through, especially when people are in bed. So it's telling me there's a leak in that property somewhere. I might be able to talk more on this afterwards, but out of the 22,000 properties that we started with, approximately 800 of them had a leak. Now, before we put these in, I sent all the wonderful leak detector men round, listening on every service for a leak. And they found lots and repaired them. There was 800 that they didn't find. And these are good men. They're not poor workers. They're dedicated. They're very motivated. They want to do a great job. There was 800 that they didn't find. And the average loss was 10 to 20 litres an hour on those. It made a massive difference to how we started viewing things like apparent losses, or what we allowed for nighttime flows. Because when you look at district meters or water main flows, nighttime flows, you've got to make an allowance for what people use at night. We actually proved in these cases what they were doing. Okay, now in Australia we had a drought on, not quite as bad as what you've got here, just after I'd put all these in. And when I found all these leaks, I had to say to my staff, don't tell anybody, because I want to see what happens to these leaks over a period of time. And I'll rush with this a little bit. The leaks actually came obviously from lots of different things: plumbing, underground pipes, toilets, etc. But there you are, the vast majority were toilets, some even hot water systems. And this is what I wanted to find. I wanted to monitor every day what the graph would show me, and then send a plumber in after a while to find out what the leak was. So our meter people could then, whenever they got a leak showing up, they could see what sort of graph is it giving, and we could tell the people, the consumer, the customer, not just that they've got a leak, but exactly what the leak is. Whether it's on a tap, whether it's a toilet, whether it's an underground copper pipe, whether it's an underground plastic pipe. I got all these shapes developed, and this was one pipe that kept breaking every time it had been repaired. So gathering data and gathering information about not just apparent losses, which is what drove us on this, but getting better information to make management decisions, to find out really how much the real losses are by finding out what the apparent losses are and what it breaks down to. It's also extremely good during a drought condition, because this particular graph looks at about, I can't remember, 140 metres in one particular area. That's domestic metres. And we noticed a blip at night time there. We went into all the metres within that area, and we found out an offending customer who was watering all his lawns in the middle of the night. You can see here when we looked at that 1 metre, between 3 AM and 4 AM each day, a massive amount of water going through. And we thought he's either filling swimming pools or watering grass, when it was illegal to, because we're in a massive drought. So again, smart metering can help give you other information as well. And that's a similar situation. But I think I'm running out of time, so I'll come back to these. When I said you do samples as well for looking for leaks, for looking for stolen water, we actually went round and we dug up at random samples. We dug up 100 metres. We actually did other tests first. We make sure we'd go and open a tap in a house or a property, measure out what the water flow was in there, and make sure it was going through the meter. If the meter wasn't turning round to that flow rate, we then actually dug it up to see what's happening here. And this was not unusual. So apart from being in Australia, we're not always the brightest. We're thieves as well. In fact, this is why England kicked us all out about 200 years ago and sent us to Australia, because we're thieves. But we're good at it, you see. We do nice plumbing to get round it. So all I'm saying is there are ways, and you've got to do audits, and you've got to have an audit trail to prove to a nasty CEO like me that you're doing your job for gathering all that data as well as what you can. All right. Now, I put this slide up with nearly every talk. A wonderful man called Henry Ford. He had this great saying that I like, is whether you think you can or you can't, you're usually right. If you say, I can't do all this, it's too complicated, or I can't, it's so many issues to determine what the apparent loss is, I'll say, well, you're obviously not the right person to do it. You know, I need to get somebody else in. Because if you believe you can, and you go out and try and achieve, actually you will be successful. There's no doubt about it. Because wherever hurdles you come up again, you'll get over them. You'll find out the details. So if there's one takeaway message with you, please take this, because it's really motivational, and tell your people as well. If you believe you can, you will do. Don't be the negative person. Okay, thank you.